The overall goal of this procedure is to culture thymic medullary epithelial cells, or MTECs, in a three-dimensional organotypic culture, or OTC, system. This is accomplished by first placing the fibrous scaffold material into a 12-well filter insert, followed by the layering of a freshly prepared fibrin gel containing human skin fibroblasts. After 4 to 5 days of pre-culture, the MTECs are seeded onto the scaffold and cultured under submerged culture conditions. Ultimately, immunohistochemistry, RNA isolation, and FACS can be performed on the co-cultures to assess the development of the seeded MTECs.
The main advantage of the 3D organotypic co-culture systems versus the existing 2D culture systems is that they are far superior in recapitulating MTEC differentiation, proliferation, and the maintenance of promiscuous gene expression. Today, demonstrating this technique will be Iris Martin, a technician from our collaboration laboratory.
When the human dermal fibroblasts reach confluency, prepare the scaffold fibers by boiling, drying, and ironing the 0.4 to 0.6 mm thick pieces of viscose nonwoven fibrous material. Use a metal hole punch to cut them into 11 mm circles. Place the cut fibrous material between 2 slides, wrap the slides in foil, and autoclave them. Once sterilized, place the inserts into wells of a sterile 12-well plate, and then each scaffold into a corresponding insert. Next, mix 2.7 times 10 to the 5th fibroblasts in 100 microliters of fetal calf serum into 100 microliters of freshly diluted thrombin per scaffold. Dispense the thrombin fibroblast mixture onto each of the scaffolds, followed by 200 microliters of freshly diluted fibrinogen. Then mix the cell mixture within each well, distributing the solution evenly over the whole scaffold with gentle pipetting. The image shows the growth of the human dermal fibroblasts with the fibrin gel at day 1 and day 4 of culture. Prepare a test gel in a control well without a scaffold to track the time and formation of the clots at this time as well. Assess the clot formation using a pipette tip or by inverting the plate. After the fibroblasts have clotted, submerge the organ cultures in medium supplemented with L-ascorbic acid and TGF-beta1 for 4 to 5 days. On the day of the MTEC seeding, replace this medium with RFAD medium containing 500 units per milliliter of protein to prevent precocious fibrinolysis. 7 to 8 hours later, seed 2.5 times 10 to the 5th MTEC suspended in 100 microliters of RFAD onto the top of each scaffold, and incubate the co-cultures for 24 hours. The next day, replace the medium with fresh medium containing 250 units per milliliter of a protein for 4 to 7 more days of culture. To assess the development of the MTECs by immunohistochemistry, at the end of the culture, use a pair of forceps to separate the scaffold dermal equivalent from the filter of each well insert and embed the OTCs in OCT compound. Freeze the OTCs in the gaseous phase over liquid nitrogen. To isolate the OTC RNA, after separating the scaffold tissue from the filters, use a scalpel to cut the OTCs into pieces and transfer the pieces into a 2 ml RNase-free tube containing 1 ml of denaturing solution. Using a fast prep instrument, mechanically shred the OTCs twice at a speed of 6.0 for 30 seconds each time, with a 2-minute rest period on ice between each shredding. Then isolate the RNA using acid guanidinium thiocyanate phenylchloroform extraction as described by the manufacturer. To analyze the OTCs by flow cytometry, remove the membrane and separate the scaffold from the fibrin fibroblast MTEC gel, and then finely cut the gel with a scalpel as just demonstrated. Transfer the tissue into a fax tube containing 2 ml of collagenase dispace. Then place the tube in 37 degrees Celsius in a water bath with magnetic stirring for 20 minutes, agitating by Pasteur pipette once every 5 minutes. When the tissue is completely digested, filter the resulting cell suspension through a 70 micrometer strainer, and stain the cells using the appropriate antibodies. As illustrated, the MTECs can be identified by their keratin 14 expression, making them easily distinguished from the vimentin-positive fibroblasts. Interestingly, the immature and mature MTECs exhibit different but highly reproducible growing patterns in culture. The immature CD80 low MTECs, for example, typically form bilayers in close contact with the fibroblasts, while the CD80 high MTECs tend to form compact cell aggregates delimited by the fibroblasts. The MTEC subsets do not just survive, but proliferate under the demonstrated 3D OTC conditions, as evidenced by their EDU incorporation. Interestingly, the CD80 low MTECs proliferate at a higher rate in the presence of rankle, while the reverse is true for CD80 high MTECs.
After watching this video, you should have a good understanding of how to culture MTECs using 3D OTCs. This is a method far superior to using 2D culture systems in terms of tech differentiation and PGE maintenance and induction, with the potential for studying or manipulating several tech parameters.